Hello, sixth grade. So before you take a look at this video, you need to have completed the study guide in the book. So if you haven't done that, stop right now, go do it, and then come back. All right, so here are the first four answers. Take a look at them and see how you did. Now, for 1 and 2, you might have been able to do that with mental math, understanding multiplication. But probably 3 and 4 would have maybe taken a little bit more effort. So I am going to write out the factors of each of those numbers. All right, so I know 1 in 36 and 1 in 90 are going to get it done, right? Now I'm going to go through the divisibility rules for each of them kind of at the same time. So is 2 a factor of 36? 36 is even, so 2 is a factor. Now I happen to know 2 times 18 is 36. If you didn't know that, you might have to do a little bit more work. I also know that 2 times 45 is 90. Now remember, as you do this, whenever you come up with a factor on a factor list, that means all the factors of that factor are also factors of whatever you're working with. So that means all the factors of 18 are going to be part of 36, and all the factors of 45 are going to be factors of 90 also. So that might be helpful to you. So I'm continuing to go through the checklist. Is 36 divisible by 3? Well, the rule for 3 is we're going to add the digits. 3 plus 6 is 9. 9 is a multiple of 3, so I know that 3 is a factor of 36. The same thing over here because 9 plus 0 is 9. Again, 9 is a multiple of 3. So I know that 12 is going to go with 3 here, and 30 is going to go with 3 here. And so now I can keep going. If I see a 12 on this list, I know that 4 is a factor of 12. So I don't even have to go with the 4 rule here. I could apply the 4 rule here, or just know that 12 divided by 4 is 3. So that means 4 must be a factor of 36. 4 times 9. And actually on the test, a lot of you missed 4 times 9 is 36. And then 6 squared, right? 36 is a square number, so 6 is a factor by itself. And we don't repeat, right? Some of you repeated on last week's test. Okay, so now 4 is not going to go into 90. I know 5 will though, although I don't know how many 5s. 6 is, remember the 2 and 3 rule? 2 and 3, yes, that means 6 works. And again, not really sure what goes with 6. 7 is not going to work. 8 not going to work. 9 is going to work, and 9 times 10. So now 9 times 10 is helpful because there's a relationship that I could use. Well, I guess I could use 3 and 30. To find 6, I know that 6 is double 3. Half of 30 would be 15. That's how I can get that. And then 5 and 10 have a relationship. 5 is half of 10. That means I could take 10's partner here, 9, and double it to get 18. So now we have all the factors, and if I look closely, I can see 18 is the greatest common factor. That one might be hard to do without listing the factors out. All right, on number 4, we were looking for greatest common factor for 45 and 75. And you know, right away, I'm going to have like thinking about 5s, right? Because we have a 5 in the ones place. 5 times 9 here. 5, how many 5s make 75? I don't know. But I also know that 25 is a factor, right? How many 25s make 75? 3. So I'm going to put it up there. You see, I don't have to list 1 in itself right now if I know that there are other factors because we're looking for greatest common factor. What else? Well, maybe I do need to do 3 here. I know that 4 plus 5 is 9, and so that means 3 is a factor. What times 3? Well, I want to show you another little trick. You know that half and double? We can do the same thing with triples. So triple means you multiply by 3. So if you multiply one of the factors by 3, you could divide the other factor by 3 and have the same product. So I see right now that 3 times 3 is 9. That means that this factor divided by 3 is going to give us 5, and that makes it 15. 3 times 15 is 45. What else? Oh, we still need to figure out what goes with 5. Well, if 5 5s make 25, then this divided by 5 is going to give us 3. 3 times 5 is 15. 15 is the greatest common factor. Just a little bit of math manipulation there, number manipulation to get that answer. All right, on number 5, this word problem, they wanted to know the greatest number of groups the principal could make. She had 28 girls and 32 boys to work with, and the greatest common factor there is 4, so we could answer that question as 4 groups. All right, number 6 and 7, are a little bit challenging, writing the sum of numbers as the product of their greatest common factor and another sum. So this is where we're looking for the greatest common factor for 32 and 20, and I happen to know that that is 4. And so what we're going to multiply that by then is what happens when we divide each of those addends, that's what you call the numbers you're adding, by 4. Well, 32 divided by 4 is 8, and 20 divided by 4 is 5. And so that becomes a sum that we're going to add together to get the other factor. So 4 is one of the factors, and then the sum of 8 and 5 is the other. So 4 times 13 gives you the same result as 32 plus 20. So on the next one, we have 18 and 27. 9 is the greatest common factor. And so I'm going to divide 18 by 9 to get 2, and 27 by 9 to get 3. And so 9, the greatest common factor, is our first factor. And then the sum of what we get when we divide each of the addends is the other one. So 9 times 5, which happens to be 45, is the same as 18 plus 27. All right, the next section on least common multiple, you can just list the multiples out. 6 and 12, that one's pretty clear cut. 30, 6 and 10. 8 and 9 is 72. Now that one's interesting because what do you get when you multiply 8 times 9? You get 72. Anytime you multiply the numbers you're trying to find the least common multiple of, you're always going to get a common multiple. It's not always the least one. So for instance, on 6 and 10, we could have multiplied 6 times 10 and gotten 60, which is a common multiple, but it's not the least. 30 would be the least. But in this case, 8 times 9 is 72. That is a common multiple, and it is the least common multiple. And then 9 and 12 is 36. All right, so let's look at number 12. Juanita runs every 3rd day and swims every 5th day. If Juanita runs and swims today, in how many days will she run and swim again on the same day? Well, in this case, 3 and 5, their least common multiple is 15, so it would be 15 days later. So problem 13 is one that kind of gives students some difficulty sometimes. Is understanding when you use greatest common factor and when you use least common multiple. So the question is, what types of problems can be solved with greatest common factor and what types of problems can be solved with least common multiple? So in greatest common factor, like the one above on the school coming up with groups, when we have amounts that are split into the same number of groups, that's going to be a greatest common factor problem. And just like on this Juanita's problem about a schedule, events that occur on the same schedule, when you're looking at that, you're looking for least common multiple. Okay, on the next page, you have some yes, no, true, false questions. Whenever you have those kind of questions, you just got to read through it and try it to see if it works. So on the first one, you're looking for multiples, common multiples. It doesn't work on the 20th customer, but it does work on the 40th and the 160th customer. And then greatest common factor questions, true, and then false and false. If you got those right, good for you. If you didn't, you might want to take another closer look. All right, on number 3, we're looking at reefs in the Pacific Ocean, and we want to compare depths. Now, the depth is the amount of space under the surface, right? So one of the reefs is negative 27 meters, and the other one is negative 31. And Martina thinks that the negative 27 reef is deeper because negative 27 is greater than negative 31. But the reality is we're comparing how far down each of the reefs goes. So you have to think about depth as not in terms of negatives, but how far below. And then you're looking at how far, because the one that's lower has further to go to get to the surface, right? So reef B is 31 feet below the surface. Reef A is only 27 feet below the surface. So reef B is deeper. Okay, this last problem is a great one. This is kind of like the hot dogs and the hot dog buns we talked about the other day. Tia's buying paper cups and plates. Cups come in packages of 12, plates come in packages of 10. She wants to buy the same number of cups and plates, but she wants to buy the least number of packages possible. So we're looking for least common multiple. The least common multiple for 10 and 12 is 60. And if you list them out, you could see that. So the least common multiple is 60. Now, how much should she expect to pay if the package of cups costs $3 and each package of plates costs $5? Well, if she's going to buy 60 cups and they come in packages of 12, she would have to buy 5 packages, right? So she's going to buy 5 at packages of cups cost $3 each. So that is equal to $15. And then she needs to buy plates out of that are packages of 10, and she needs 6 of them. So 6 of those at $5 each would be $30. So you add that together and you get $45. Now, it said to explain. I kind of said it as I went, but hopefully you put that into words. And there you go. Hope you did well.